going on page 102 when we are done. Now, we just looked at with our little pyramids and prisms there. We came up with the volume of a pyramid. And notice that it says volume of a pyramid, not right pyramid, like it did for surface area. It works for right pyramids, oblique pyramids, regular pyramids, irregular pyramids, works for all of them. So the volume, when you have base area big B and height h, volume is 1/3 big B times h, right? That is it. We came up with that with our little pyramids. Now let's go and actually find the volume, because these formulas aren't new to you. But again, a lot of times I think that formulas are just thrown at you and you're told do this because I said so, and you don't know why and how they work and all that kind of stuff. So volume is equal to 1/3 big B times h. So I have to go and find big B. What would be my big B formula? Good. 1/2 AP, which means I need the perimeter, which is n times s. So what is n in this case? 6. What is s? 10. So your perimeter is 60. Right? So did they give me the apothem? No, because they really rarely ever do so. I'm going to come and draw this in here, right? That's my apothem. That's my central angle, which is 60. So I'm going to draw this out here. And when it's a hexagon especially, this should be getting easier and easier for you. This is why I've made you do it over and over again, because I know it's going to keep coming up. I know that this angle is 30. What's this length right here? 5. So my apothem is 5 square root of 3. So now I can substitute this in, and I get 1/2 times 5 square root of 3 times the perimeter, which is 60. So that means big B is what? Good. 150 square root of 3. All right. So now I have big B. I need h. Did they give me the height? No. What did they give me? Slant height. So I'm going to come draw in the height. Okay. And then I'm going to redraw the slant height here on the other face. That is 16. And this is the height that I need. It's like behind it. And then I'm going to connect them to get this right triangle. And so this triangle is like floating inside there. Do I have enough information to find the height? Yes. I'm going to use h, 16, and what? The apothem, 5 square root of 3. And see how I drew in that little triangle even though I didn't really use it in that picture? If I hadn't drawn it in, I might not be able to see that connection and understand that I already have that number there that I need. So now I do Pythagorean theorem. H squared plus 5 square root of 3 squared equals 16 squared. No, the slant height cannot be one of the edges. They could give me an edge, but it's not the same as the slant height. Because if you notice, like, if you can see that this one is on the space that's facing you, it's the height of this triangle. So the edge right here would actually be like the hypotenuse of that triangle, and so it's a different measurement. That's a good question. Yes, it'll always go to the midpoint of the base, yes. Right. Yes. 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 For the triangle, is that what you're asking me? For this part. Okay. So that's a very good question. So our question is, how do I know which one to use, whether you're using the apothem or the radius? Is that what you're asking me? Okay. Because if I was going to use the radius, so let's just look at it from here to that radius, because it's the same, but I don't want to confuse you with that. So if I do this, and it is perpendicular with the height here, the third side that would be that edge that Jennifer was asking about. I think it was Jennifer was asking about. Does that make sense? It's a different triangle. So since I don't have that information, I'm not using the radius. If I had that, then I could. Does that make sense to you? It's which parts are actually matching up. And the apothem goes to the midpoint, and so does the slant height. And so those two intersect right there, and then the height intersects right there. Okay, does that make sense? Those are good questions. Okay, anything else? Okay, good deal. All right, now tell me, with this Pythagorean theorem I wrote down, though, what's wrong with what I wrote down? I need parentheses, because I got to make sure that I don't just square the square root of 3, right? So I get h squared plus, what's 5 squared to 3 squared? How do I do that? Good, it'd be 25 times 3. 5 squared is 25, square root of 3 squared is 3, right? Okay, so 25 times 3 is 75. That's equal to 256. Okay, so before I even ask you what h squared is, I've just gotten random numbers yelled at me all day, so let's talk about this. You are in control of how much you subtract at a time, okay? So when you're trying to do that and not, write a bunch of stuff down and you're trying to do it in your head, make it easier on yourself. Instead of just trying to subtract 75, let's start with 50. So 256 minus 50 gets me to 206, right? Then I still have 25 more I have to subtract. So I'll go ahead and take the 5 out. So that gets me to 201, but I still have 20 to subtract out. So 201 minus 20 gives me 181. Does that make sense? That's why I keep saying to you, think in terms of money. Because if you actually had money in front of you, you don't have a $75 bill. It doesn't exist, right? But you could have a $50 bill, a $10 bill, a $20 bill. And so it's like a no-brainer when you have money. Y'all can count through that stuff quickly. Think about these types of things in terms of denominations of money, and you can kind of reduce things at your own rate, however you want to do it, a whole lot quicker, because y'all are good at that stuff, right? And it just makes it make a little bit more sense. All right, so h is equal to the square root of 181, and I'll just go ahead and tell you that's a prime number, and there's nothing we can do with it. It's just ugly. So I'm going to substitute this in 1/3 times big B, which is 150 square root of 3, times the height, which is the square root of 181. So what can I take the third of? 150, right? So this is going to be 50. Then what can I do with those square roots? Multiply them, because when you have square roots, you can multiply everything outside together and everything inside together. So we need to multiply the 3 times the 181. What's 3 times 100? 300. What's 3 times 80? 240. And then 3 times 1 is 3. So that gives me 543. Now that's a pretty big number underneath the square root, but if you try to simplify it and you start a tree, what two numbers do you get? 3 and 181, right? And they're both prime, and you can't do anything, so you just multiply them right back, so there's no reason to try. So volume is equal to that, and I know it looks ugly, but that's okay. There you go. Ugly answers are okay. We good? Any questions? All right, so now we're going to find the volume of the composite figure, and the prisms are right prisms. Now, are volumes for composite figures a little bit easier than surface areas? Yeah. So really, I can look at this as 3 different figures, and I can find the volume of each and then do what? Add them up. So I'm going to talk about it as 1, 2, and 3. So the volume of 1 plus the volume of 2 plus the volume of 3. And if you named them differently or talked about it differently, it would be fine, but that was just the easiest thing to do. So we'll start with the volume of the first one. It's a prism, so it's big B times H. What would my big B formula be? Good, 1/2 base times height, because the base is a triangle, right? So what is the base and the height of the triangle? 4 and 4, because they're marked congruent. 4 times 4. So big B is 8. So I get 8 times, what's the height of that prism? 3, because it's the distance between the 2 bases, so it is 3. So your volume then is, for the first one, 24. Okay, we good? So then I go on to the volume of the second one, and that is also a prism, so big B times H. What would be your big B formula here? Base times height. Good. And what is the base and the height of the base? 5 times 3. Good, because this is your base, or that is your base, and so we get 5 times 3, so big B is 15. Okay, so this gives me 15 times, what's the height? It is the distance between the bases, and it is 4. Volume of 2 equals 60. So then we got to find the volume of the third figure. And that is 1/3 big B times H. What is the big B formula for this one? Well, the volume is 1/3 big B times H, but then big B itself, okay, good, it's just base times height. So what are the base and the height of the base? Okay, so this is the base here of the pyramid. So it's this, which is 3, and this, which is 4. 3 times 4. So big B is 12. Are you confused as to why? Okay, you got it now? Okay, that's fine. So we get 1/3 times what's big B? 12. What's the height? 4. 1/3 of 12 is 4 times 4 is 16. Okay, so I found the volume of each one of the things I needed. I've got everything that my plan said I needed. So now I've just got to put it together. 24 plus 60 plus 16. What does that give me? 100 inches cubed. Now, this was a fairly simple problem. That's why I did it kind of quickly. I mean, you didn't have to go and calculate a value. They were all given to you. You just had to know how to use them. But quite a few of you struggled on which number to use. So you can make a really easy problem really wrong by not understanding which piece is which and what you're supposed to be using. Does that make sense to you? Okay, good. Any questions? All right. Next one. So the rainforest pyramid in Galveston, Texas is a square pyramid with a base area of about 1 acre and a height of 10 stories. We're going to estimate the volume in cubic yards and in cubic feet. Okay, so we're not actually going to calculate that. I'm going to give it to you because I want to talk about something different but still related to this. So I'm going to give you that the volume in cubic yards is 484,000 divided by 9 yards cubed. Okay, so that's the volume in cubic yards. The question asks for, because really, if you can find the volume of a pyramid, you just do all that, the numbers are big. But we're supposed to give the answer in cubic yards and in cubic feet. So we're going to talk about the conversion. How many feet are in a yard? 3. So if I have 5 yards of something, how many feet do I have? 15. If I have 5 yards, I have 15 feet, okay? Because there are 3 feet in a yard, so for every 3 feet there is 1 yard, right? So I want to know how many feet are in 5 yards. Yeah, okay, it's not 1/3. All right, so basically I would take the number of yards that I have and multiply it by 3. Would y'all agree with that? Okay, so since I need my answer in cubic feet, am I just going to take this answer and multiply it by 3? The answer to that is no, okay? And the most important thing that you get out of this example today, because we're going to keep coming back to this idea, is that dimensions and volume and area change at different rates, okay? Yes, there are 3 feet in a yard. There are not 3 cubic feet in 1 cubic yard. Okay, it doesn't work that way. So I want you to look at these tiles on the floor as an example. These are 1 square foot tiles. So the dimensions are 1 foot by 1 foot, which makes the area 1 square foot. Make sense? So we know that there are 12 inches in 1 foot. Does that mean that there is 12 square inches in there? No, because the dimensions in inches would be 12 times 12, right? Which would give you 144 square inches. So when you're converting area, you don't just multiply by whatever the conversion is. You have to multiply by whatever the conversion is squared because you have 2 dimensions and both of them change, and whatever that change is then gets multiplied together. Same thing happens with volume. Okay, so this is my volume. This is a prism here. If I was to double each dimension, okay, the volume itself for the new figure doesn't get doubled, because I'm going to multiply basically length times width times height, right? And all 3 of them got doubled. So this is 2 times more, 2 times more, and 2 times more. So those 2's get multiplied together as well. Does that make sense to you? You have to convert each thing. And if it's a 3-dimensional thing, there are 3, even its volume, you have to do that conversion 3 times. Right? So here's how this works. If I have 1 yard, I have 3 feet, right? If I have 1 yard squared, how many square feet is that? Think about the squares here. If this square was 1 yard by 1 yard, that'd be 3 feet by 3 feet. So 1 square yard is 9 square feet, right? And 1 yard cubed would be how many feet cubed, do you think? It would be 3 times 3 times 3, which is 27. You multiply too many times. 27. And there's an exponent in all those. That one is kind of hidden. We wouldn't really write it, but I want you to write it right now because I want you to see what's happening here. Yes, whether it's talking about just normal dimensions, area, or volume. It's that the rate at which it changes is different. So this 3 represents 3 to the first power. This 9 represents 3 to the second power. 27 represents 3 to the third power. And do you see how these match every single time? So when we wanted to convert this 1 square foot into square inches, I know my conversion is by multiplying by 12, but I have to do it twice. I take 1 and multiply by 12 and get 12. Then I do it again, and that's where I get 144 from. But multiplying it by 12 and multiplying it by 12 again is the same thing as multiplying by 12 squared, right? So since this is cubic yards, I got a few options. I can't just multiply by 3, but I can multiply by 3 and then again and again and do it 3 times since it's cubed, or multiply by 3 cubed, which is the same thing as 27. So the exponents on your units tell you what the exponent on the conversion has to be. And the conversions are the same. You're still converting feet to inches the same way you did before, and feet to miles and millimeters to meters and things like that. Okay, but these kind of conversions are going to come up in your science classes and honestly in your real life as well. So at the very least, you have to understand that it's different and that you can't just multiply by 3. Right? So, because what we're going to do here is we're going to take this 484,000 divided by 9, and since it's cubic yards, we have to multiply by 3 cubed. This 3 comes from the fact that there's 3 feet in a yard. This cubed comes from the fact, this 3 comes from the fact that it's units cubed. Now, when you actually do it, we would adjust that to be 27. It's like I wanted it there, but we'll just change it to 27. Then when you multiply that stuff, what you get is 1,452,000 cubic feet. Real life, you may need to think about these things at one point. You may not have to actually do the conversion, or you might be able to do it on a computer or a calculator, but you need to know it exists and that it's different. Okay, if you ever want to remodel your house and you're going to go get stuff for your kitchen, okay, there's things that you have to buy in square feet and cubic feet and linear feet all the time. So like countertops, right? There's a what's it called? Not a consistent, but there's a uniform depth to countertops, right, for your kitchen or for your bathroom. And unless you have something super custom, everybody's is pretty much the same. So they don't talk about countertops in square feet, even though it's like an area type thing. They talk about them in linear feet because it's just easier to understand, like how long is your countertop. It's no need to calculate all the rest of it. That's just a linear measurement. That's what a linear foot is, something you can measure with a ruler. But if you're going to do your backsplash or your floor, then you're talking square feet, or possibly square yards. And that's where this comes into play, is that when you go shop for carpet or sometimes for tiles, if they're like ginormous ones, you're going to put them outside or whatever, they could be, the price could be per cubic foot, or I'm sorry, per square foot, or it could be per square yard. And so the prices will be very different because those are actually telling you very different things. But if you don't know how to convert it right, you can be very confused on how much you're actually spending. And they kind of do that on purpose so that you really don't know how much you're spending. And the salesman probably doesn't really understand it either. Or they're just punching buttons and they told them how to convert it and they don't know. And I'm not saying you're going to have to be in Home Depot and like convert on the fly and be like, oh, I know how to do that math. But at the very least, know that you don't get to just divide by 3 or multiply by 3, that it is different. And if you need to go look it up so you do it right, or use a conversion calculator, but know that it's different so that you're not getting screwed at the checkout. Okay? But that's something that really might show up in your life, and you might be the one in your family going, oh, no, wait, we got to look at this, right? That's what I'm usually doing with my husband. No, that doesn't work that way. No. Hang on, wait, let me do the math here. Okay. I know. It's like, wait a minute. Yeah, I don't know. One day I'll tell y'all about him trying to put a border around our spa outside. It was a disaster, but we don't have time today. All right. So the volume of a cone with the base area, big B. Now, cones and pyramids, very similar to each other, right? So we could use the volume equals 1/3 big B times H. That totally works, and that's what we did for pyramids. But I can make it more cone-like and use pi r squared H. which means instead of that being a third of the prism formula, it's a third of the cylinder formula. Now, I can't give you 3 cones and you fit them to be inside of a cylinder because there's nowhere for that third circle to go without you actually like morphing it into something. But that is something that I could show you with like pouring sand or pouring rice, but I don't have that with me today either, so you just have to take my word for it. Because again, you should have already seen it. Sorry, I can't redo everything. All right. Okay, so we're going to find the volume of this cone. Volume is equal to 1/3 pi r squared h. So what's the radius? 16, right? And then did they give me the height? No. They gave me the slant height. This is the height, right? So how do I find the height? Good. So h squared 16 squared equals 34 squared. And then you can go through and find h, right? You're capable of that. And then you would just substitute it in and you're good to go. Did you agree with that? Okay. So we're not going to actually work the problem. I just wanted to point out that you've got to be careful with the slant height and the height thing. Okay. But there's no need to do that because they're all just the same of substitution. Because I want to have time to talk about this next one. All right, so this says find the volume between the cylinder and the truncated cone or frustum. All right, so some new vocabulary there. If I have a plane that comes through and slices through my cone, we talked about cross sections, right? This cross section would be a circle. But what it creates by taking this top off is it creates a truncated cone, meaning basically that the top got chopped off. We'll look at some other truncated figures. Or also what's called a frustum. And those words can come up again for you like in calculus, so I don't want it to be the first time that you've heard them. We'll use them some more, we'll talk about them some more, but that's why it's on there right now. So this is kind of what we have, except the one on the picture is a little bit shorter. But then also there's a tunnel dug in here. There's a cylinder dug out. This is a hole that you could actually go all the way through, just like all the rest of our composite figures. Okay? Does that make sense to you? So you've had a cone with its head chopped off, and then a cylinder got drilled through all the way through the inside. So I want you to label what it says, first of all, and then I want you to come up with a plan for volume. Remember that volume plans are a whole lot easier than surface area. But go ahead and label all what it says. Think about what a plan might be while I pass out the homework, and then we'll talk about the plans. So just oh, I did. Okay. Wasn't sure if I counted right. All right. So the radius is 3. This is a 9. Okay. So it talks about the height of the original cone. Do you know what that means? Basically. Okay. Before it got chopped off. So would it kind of help to have that in there, right? So I'm going to draw it in, but I'm going to make it a dotted line because it doesn't really exist, and I don't want to think that I can actually. It's actually part of my picture. So something like that. So I could draw in the original height, right? Oh, I don't guess I had to put h because they gave me what it is. What is it? 40. This whole thing here is 40. All right. So how many volumes am I going to have to find in my plan? 3, right? So you can talk about original cone and small cone or whatever, but don't really necessarily just talk about it as like the top of the cone, because the top of the cone that gets cut off is what shape? Is a cone. So instead I want to talk about, both of them as cones themselves. So I'm going to call them, so I can write less, big and small. But you could have numbered them. I just think my numbers might make it confusing. So I can start off by finding the volume of the big cone. Do you agree with that? Then what can I take off first? Subtract the little cone. So I'll subtract the volume of the small cone. Then what do I need to do? The volume of the cylinder. Okay. Does that make sense? Everybody okay with that? That's way more straightforward than a surface area thing. Now, in order to find these things, we have to have the radius and the height. Then if we have that, we just substitute them in formulas just like a piece of cake. So let's come up with the radius and the height for each one of those. All right. So what's the radius of the big cone? 12. 9, it says, is from here to here. That is 9. Because it says between the edge of the base of the cylinder and the edge of the base of the frustum is 9 centimeters. This length here is what? 3, because it's that radius. So this whole thing is 12. So be careful with that. All right, so then what's the height of the big cone? 40. Good, because it gave me that. And then small cone, what's the radius? 3. What's the height? You need to find it. How are we going to find it? Good. 40 minus 21, and that gives me 19. And cylinder, what's the radius? 3. Height is 21. Okay? And that's all that it's required for those formulas. So then it'd be a piece of cake to put everything together. I just don't think we need to do it. But we're good? These weird figures are getting a little bit better, right? Because we're going to continue to get some more weird ones. So just know that that's why we keep looking at them. Now, this one here you've seen before. We did it with surface area. I think I changed the numbers, but we had done it with surface area. But now this is volume, so it's a very different plan. I can just find the volume of what first? The prism. And then what? Subtract the volume of the pyramid. Good. That's okay. I'm not subtracting it from the volume of the pyramid. I'm subtracting the volume of the pyramid. Those are two completely different things. I'm subtracting the volume of the pyramid from the prism. Okay, think about that. That's what y'all say backwards a lot. So be careful that you really understand what's coming out of your mouth. But again, we're not going to actually find that. But are we good? Because you're capable of finding the pieces. All right, good deal.